Hi, and welcome to the Keith Bryant Show. I'm very pleased and honoured to have my first guest of the week, Mr. Trevor Galbraith, who's Editor-in-Chief of Global SMT and Packaging, and way more used to sitting my side of the table than the side that he's sitting on today. So I've got some awkward and difficult questions for him, and we're going to see how he performs as the interviewee. Good morning, Trevor.
Good morning, Keith. Yeah, it makes a change to be on this side of the table, that's for sure.
Yeah, I mean, the first thing that I wanted to chat about is obviously you guys are in the middle of a lot, not only of the publication, but of technical articles, of seminars, of webinars, and a whole load of other stuff that you do. I just wondered what you were seeing as, let's call it new and hot topics.
New and hot topics, what, technically in our industry, or are you talking about in the publishing side?
Well, first of all, in our industry, and then we get on to our webinars, the new seminars, and all of this kind of stuff. But let's look at the technology first.
Okay, well, in technology, I mean, the industry is literally exploding at the moment with a whole range of different things. We've got smart factory technology coming in. A lot of that started last year with machine-to-machine communication. This year, the focus is very much on material supply to the line to reduce the machine downtime. So that's a big focus this year. We've also got a lot of cobots coming into factories. We've got companies using additive printing for prototyping or for tooling. So that's another area of technology. Digital twins is another area of technology to try and reduce the cost on materials. So lots of things happening at the same time, basically, and it's very difficult to keep up.
Yeah, I mean, 4.0, as you say, has been around for a year, possibly 2 years. I think it was 2015 it was first talked of in Germany. But you think it's starting to happen now, or is it still people talking about it and looking at it and trying to find a way?
Well, I think it's actually been around longer than 2015, if I can really say that. I mean, it did come out originally from Fraunhofer Institute in Germany, you're quite right. But my first exposure to it, if you like, was a Siemens company in Erlangen, and that was in 2015. And this company had 1,250 employees. That 8 years ago it had the same number of employees, but 8 years later they're making 800 times the amount of output using big data. So that was my first exposure to Industry 4.0 in action. Obviously, the first adopters of smart factory and Industry 4.0 are the bigger companies. Companies like Jabil are very much in the lead in this area. But it will trickle down to the mid-sized companies as we go forward.
Yeah, and what about in terms of broadening out the publication question? I know you're involved with some technical workshops and events, including one which is a smart factory one coming up reasonably soon. And I know you're a strong supporter of both IPC and SMTA events.
Yep.
Are you still seeing those as a relevant part of, let's say, the complete package of engaging with your audience?
Absolutely, yeah. I mean, I don't think trade shows are going to go away anytime soon, put it that way. I think a lot of engineers come to trade shows to get validation for products that they're going to buy. Admittedly, they are seeing these machines working. They're not actually running, they're doing a dry run basically, but they're still getting to see the machines, talk to the experts, etc. Conferences are also a good place for networking. A lot of people don't value networking enough. It's a very important way of gathering intelligence and knowledge about the industry.
Yeah, I was at the PAMPAC conference recently and there were some really good papers there from the Asian engineers.
Yep.
And they're making a lot of the people from the US and Europe sort of sit back in their seats and go like, kind of, wow, that's really interesting and exciting, and also very new.
Right. It's a very unique conference, actually, and that's the aspect I love about it, is that it's genuinely a meeting of East versus West, or meets West, should I say. You get a lot of very high quality technical articles coming out of Japan and China and other parts of Asia. And of course, because it's been held in Hawaii, you've got to have a pretty strong presentation and reason for being there.
Oh yeah, it's a tough ask for the boss. That's definitely for sure.
Yeah.
But what I wonder is we have very good, let's call it, cross-pollination from Europe to the US. You also have a German language magazine.
Yeah.
Should we be trying to pull more content out of China and out of Japan for, let's say, not just yours, but our publications generally and our conferences? Should we be looking to try and get those people to come and talk directly to us? I know that's not an easy ask.
No, it's not. And the answer to it is, of course, yes. But let me give you an interesting analogy here. I was speaking to somebody fairly high up in Chinese government circles one year in Shenzhen when they just announced a 1 trillion RMB budget to develop their own version of Industry 4.0. And my question was to them, well, why are you reinventing the wheel? Why are you not using the same systems that the rest of us are using? And the reply I got was, well, China are very happy about all information coming into the country, but we're not so happy about information leaving.
Yeah, I suppose when you get that kind of comment from a government, it's a tough one. But you still have Korea, you still have Taiwan, you still have Japan. There's still especially for the semiconductor industry, there's a lot of new and exciting stuff happening there.
Right. That
doesn't seem to. Yeah, I was going to say translate, but it's not translate. It just doesn't seem to move across the water to us.
It's starting to, and the obvious vehicle for it is the trade associations. You're starting to see papers coming in from IPC and from SMTA from other parts of the world. And I was speaking to John Mitchell yesterday, and he was telling me that the latest two standards one had 17 different countries involved in the standard, and the other one had 18. So we are actually starting to see participation coming from these other parts of the world.
So I have to say that's really good news, and I'm talking to David next, so I will put that question on my list and see how they're managing to keep their relevance as high as it's been historically. So that's going to be a good one. And thank you, Trevor. It's been nice to put you at the other end of the microphone, so to speak.
Yeah, I'm glad I managed to answer the questions. Thanks, Keith.
Smart factory solutions for any mix, any volume. Total integrated solutions, allowing you to focus on your business while we manage your production challenges.
Delivering innovation for over 34 years and backed by employees worldwide, Nordson Syntec's team of experts are ready to support your next adventure.
Welcome back. I'm here now with another very well-known face, David from the IPC, and we want to talk about what the IPC is doing to remain relevant as our industry seems to be moving faster and faster and becoming more and more complex. So, first of all, welcome, David.
Thanks, Keith. Good seeing you again.
You've already heard the question, so I'll shut up and let you pitch in.
Okay, so I guess the easiest way for me to lay out the things that IPC does to stay relevant is to talk about our aspirational goals. And it spells SEAS, S-E-A-S, standards, education, advocacy, and solutions. And so to stay relevant in standards, we have hundreds of committees. Now, you talk about speed, so speed is really important. And by talking to industry, John Mitchell got a lot of feedback that says IPC standards need to be updated more quickly. A lot of change going place. We want them to be up to date. We don't want it take forever to do a revision. And so we had a challenge with our committee chairs, and the challenge was come up with a process that allows ample time to achieve consensus but accelerates standard cycle. And so our most popular standards now, we reduced the cycle time from about 5 years to 3 years. And that was through a series of triage process, as well as committee meetings. We still are working on facilitating the standards development process. We've had several committees go through one cycle already. Our 610 wire harness was a great example. They actually finished early, and we're talking about going through hundreds and hundreds of comments from around the world.
Yeah, I'm aware putting these standards together, it's a huge amount of work, and reducing from 5 years to 3 is a big step. And is there a plan going forwards to reduce from this, or you think that you're now at a level that works?
Yeah, so I think we're stable at that at this point. We've talked about it, and some people have asked, but in my opinion, it takes a while to absorb those standards as well. And some companies have taken a revision off because it's adequate to stay where they are, which is perfectly fine. What we wanted to get away from, because we did have multiple times where a new change sat on the sideline for a while that the industry should have been using because we just were outside the cycle revision. And so I don't see that piece will, we won't have that happen anymore, but I don't see us going much lower than the 3 years for revisions. We have opportunities to accelerate first-time standards. We've had a variety of ways of doing that, either through consortiums or get people to provide us draft content, and we have a writer pull the first draft together. So there's a number of ways. I think our fastest standard we ever did was under a year, and that was one on power supplies or on fans. From an education standpoint, you're going to hear a lot more about IPC activities in the next few years. We have IPC Edge and our certification programs on that, but we're making a significant outreach to the industry. We did an interview, or we had interviews, we contracted to have an interview done with 1,000 of IPC contacts, both members and non-members, globally, and talk to them about their education needs. Severe lack of new employees was identified. People retiring, trying to get into high schools and middle schools, trying to indicate to students, hey, there's career paths here, and here's how you might do that. And so I've added 3 people to my team recently, have a couple more still to add. John Mitchell's added some additional staff members, so we're making an investment in that. We will be doing a lot more outreach in the next few years. We are building a roadmap for IPC's education globally, and so you'll be seeing more on that for the future. So again, pulling information from 1,000 companies to help us do that. From advocacy, we're doing quite a bit. We are expanding. We've had probably since the mid '80s an advocacy effort in the U.S. We have for the last several years had an advocacy effort in out of Brussels, and we're in what I would say early stages. So again, talk to the members. What issues are relevant and important, and we're tracking those so that we can provide information on the challenges or the topics that are of our highest importance to them, and then we'll decide what type of lobbying, if any, needs to take place. But that's new, and we're considering doing the same thing. We're in the process of doing something similar in China. And from solutions standpoint, Sanjay Hooperkar, one of my colleagues, has been moved over to the solutions side, which we're seeing that as an incubator, where we get lots of interesting ideas and just haven't been able to, with all the things that IPC does, just to be able to spend some time to percolate this new idea, bring it to market, check out whether there really is a market demand or if it's just the shiny item that one company puts up. And so Sanjay is leading our solutions efforts. So I'm hoping that you'll see new offerings that come up based on Sanjay's efforts within IPC.
Wow, so that's a whole wide variety of plans. If I can just go back and pick up on the education one. We know we struggle to get younger people in at let's say most levels within our wonderful industry, because it doesn't have the appeal that it did when you and I started. So what do you think we can do beyond IPC as an industry to build the excitement of what we do? We end up building some really great products for some really great companies, but it doesn't seem to translate into the interest for the young people that would take apprenticeships and lower jobs and basically come into our industry for a career.
So it's on our roadmap, but not tangible yet at this point. Apprenticeships was we just started talking apprenticeships within the last couple weeks at IPC. So with the addition of with the addition of staff member with experience in the educational space, we're looking at all these things. I can tell you a couple apexes ago, we had a keynote from Dean Kamen, who was involved with some of the FIRST robotics. There's a VEX, another robotics organization, and so where we're trying to get in front of the kids that are involved in technology space. So those are two large global organizations where we think that we have opportunities for outreach to those, to expose them to IPCC. You got to get the word out at this point. I believe we have some offerings to just at least engage their interest, to support some of their. It's just we tried a little bit and stumbled, I think, and so we're going to continue more in that area. At this meeting, we have a STEM event, so we're trying to do more outreach. We have a STEM event taking place, the science, technology, and engineering, math. We're going to do that on Thursday. I believe we have 60 to 70 students that are going to come in and see me make a printed circuit board. So we're going to do that. So I think there's opportunities. You just got to create a plan and go after it, and we'll see whether we're successful. We will reach out again to some of these other robotic associations and see if we can get them engaged in some of IPC's educational offerings, which will enable us to communicate with them and talk to them about the electronics manufacturing industry.
Well, thank you, David. That's given me, I guess, the almost perfect answer to my question, and it's really great to hear that there's a lot of future planning, that the IPC is moving faster than it did, and it's also looking at a wider range of things that are going to benefit the industry today and tomorrow and for the next 10, 20 years when we're looking at recruiting young people coming in. So thank you very much for coming in and sharing that with us.
Well, thanks for helping IPC get the word out. It's good to talk to you again.
My pleasure, David. Thank you.
Saki's newly developed unique inspection technology assures measurement performance and data reliability in M2M connection. Saki's AOI and quality-driven production are major components to the success of the Smart Factory.
Welcome back to the Keith Bryant Show. I'm here now with Brooke Sandy Smith, who I've done several of these things before, and she's been on panels, or at least she's organized panels that I've been on. So again, it's a pleasure to have a known face back. But one thing I don't know is exactly what her job is within Indium. So let's start there.
Well, I'm a tech support engineer for Indium Corporation. I was previously a product specialist for PCB assembly materials. So I've really specialized in solder paste. For the most part, I do a lot of lab work to characterize our materials and see how they fit into different applications, as well as presenting at these wonderful events and all sorts of different things, directly helping customers too.
Okay, so what hot topics are you seeing from your customers that are coming to us and saying, I have a problem with X, what can you do to fix it?
Well, I mean, voiding comes up very often, as you remember from that drove our panel discussions. And at Apex this year, I have another panel discussion on ionic cleanliness, because I think one of the really big topics in the industry right now would be the changes to the J Standard 1 regarding the cleanliness of cleaned assemblies and the obsolescence of the limit for RoHS testing related to surface cleanliness on boards post-production.
All right, so
that's not really related to you.
No. I have a history of materials going back when I had a real job. And one of the things that we were always battling with, and it leads into cleanliness, is the customer who comes along and says, how do I clean my no-clean paste? What's the, well, first of all, your view or the Indian view on, should we be cleaning no-clean, or should we be actually using a paste that we can clean when we're talking about assembly cleanliness before conformal coating or this kind of stuff?
Well, I think no clean as applies to materials is actually a misnomer. I would say you have a no clean process or you have a cleaned process. If you choose a rosin-based flux, there are still methods to clean it. You just have to use some sort of chemistry to do so. And if someone asked me, how should I clean a no clean flux, I would say completely, because the only way you can really mess that up is by partially cleaning a no-clean flux residue, in which case you're getting rid of your encapsulation that is keeping everything insulated and preventing electrochemical migration. If you're then only partially cleaning, you're leaving all of those ionic things to float around and cause you problems.
Yeah, and that's really the key issue, because by definition people say, there's a school of thought that says, okay, a flux which is designed to be left on the board, which should become inert after the correct amount of reflow process, is the best solution. And effectively, if it's inert, you can conformal coat it, you can do whatever you want over the top of it because it's inert.
Yes.
But we're seeing more and more in the industry that inert really isn't inert, or is that again a little bit of a myth?
Well, I think what you said that's critical is when you expose these materials to a certain amount of thermal energy, a certain amount of heat during the reflow process, that is critical to making them inert. So there are definitely things you can do to mess that up. You can not heat them up enough. You can have a component that doesn't allow for outgassing, or an RF shield that kind of isolates that area so that gases can't escape. So even though it's a no clean process, it's not a foolproof process. You still have to carry out each of the steps properly to end up with a reliable assembly at the end. Okay.
So which of the two should we choose? Washing or baking them after reflow to just make sure everything's cured like it should be and inert?
Both are very good options. It depends on your end goal. Conformal coating is critical, like a critical consideration in deciding which way you're going to go. Absolutely. So I would advocate for processing your boards the first time, making sure you have a good enough time above liquidus, and that you're designing your stencils to allow for outgassing under bottom termination components. And we're designing our newest fluxes to address these challenges with the newest components. So if you're having trouble, use a newer material, upgrade your material and process.
Yeah, that's good to hear. It's a little bit like one of the earlier conversations I was having with Trevor. It's like the poacher and the gamekeeper to an extent. Yeah, the technology moves, so the materials have to move. The technology moves, the materials have to move. So that's I guess probably your biggest challenge, is staying current with the technology as it becomes. Basically every time it moves, it becomes more and more demanding. So it's just got to be a continually higher and higher challenge. Yeah?
Of course. I call it progress, Keith.
Yeah, I remember that word. Yeah. But no, it's something that when I go to seminars and workshops, I'm hearing more and more that conformal coating was I won't say almost obsolete, but it was that sort of, yeah, if I have to do it and it's a high-end product, then yes, we'll look at doing it. And now it seems to be coming, washing and conformal coating are almost becoming, at least in a lot of areas, pretty much the standard process now.
Absolutely, especially for the automotive electronics sector, which is huge. It's probably our largest growing sector of the electronics industry, and those guys are pretty much always focused on conformal coating to protect these assemblies from harsh environments.
Yeah. So,
in which case, you choose a flux with a residue that's compatible with your conformal coating.
Yeah. So, are you also generating new washable products as well as, let's call them, the standard products?
Absolutely. We have a new one that's in development right now that is in scale up that we will be releasing probably by the end of the year. And I've done a lot of work in the water-soluble arena, but because probably about 80% of solder paste is no clean that's used by the industry, no clean definitely gets the prime focus, I would say.
Yeah.
As far as development.
So perhaps in our future workshops and seminars, we need to be re-promoting the old. Well, it's not old technology because it's a new version of the old technology in terms of. Okay, we'll put it on, we'll get it to do its job, and then we'll completely get it off the board before we put the conformal coating down.
Of course, water-soluble fluxes are. We make new ones all the time, but usually they're for the semiconductor industry because they're definitely going to clean them. When it comes to SMT and the larger scale, no clean is usually the choice there.
Yeah, and again, it's always struck me as strange. The semiconductor industry never really adopted no clean from the very beginning of no clean. Mm-hmm. And when I remember talking to people a long time ago when we were looking at this, it was all based around contamination. Is it going to be completely inert? Is it going to cause us problems further down the line? And now we're going through the same kind of thing within, let's call it electronics assembly. People are worrying about tin whiskers, they're worrying about migration, they're worrying about organics. And, the semiconductor guys got rid of all of this just by saying, yeah, we're not even going to adopt the technology. So. Of
course, semiconductor guys also have an easier cleaning situation. So you don't have bottom termination components with really low standoff that you can't clean underneath them with water. So there are some differences in the applications.
Yeah, I guess we have to thank those guys for giving us all the problems. Huh? Right, Brooke, it's been great to talk to you. Thank you for coming in and joining us, and have a good show.
Great, thank you very much, Keith.
I'll look forward to being on your next panel.
Great.